Hello students, in this video I am going to discuss about array and pointer concept in C programming language. Array is nothing but collection of similar data items. First we see the need of the array. Let's we check the simple program. We already know about it. In this program I am going to add two integer number. So for this program I need to use three different variables. For these three variables, I need to give the unique name. Suppose I want to add 20 numbers in my program, I need to give 20 unique variable names as well as and 20 times the variable address here. Suppose I am going to handle 200 number of variables means it is not possible to give unique 200 variable names as well as it is not possible to use this kind of method. So we need a mechanism to handle a collection of variables. That is called array. So I create a array here. For these 10 variables, I can use the single variable name called a. Using the for loop, I can easily get all the values for this array. Suppose I am going to add 100 numbers means I simply give the value 100 here. This for loop is iterated up to 100 number of times. I can get the individual array elements. So array is a collection of same data type. When we handle more number of variables, at that situation we can use the array. When we are creating array, the individual elements present in the array can be stored in the continuous memory location. Each can be defined by the index value. Suppose if you want to declare 100 variables, the index start from n of 0 to n of 99. Any one of the individual element can be accessed from the array by using this index number only. There are two types of array. One is single dimensional array, another one is multi-dimensional array. Single dimensional array is nothing but the index having only one subscript. This is the syntax for the single dimensional array creation. Data type, array name and array size. This is the index. This index having only one subscript. So this is single dimensional array. Example is integer a of 10. Here a is the array name having the 10 values. All the 10 values belongs to the integer number. When we declare a integer array like this, the continuous memory location can be created in random access memory. The starting memory location is a of 0. The next memory location is a of 1. It can be continued up to a of n minus 1. So this entire 10 elements can be accessed through the single name called a, and the individual element can be accessed through this index number. So using this concept, we can easily resolve so many real-time problems. First, we practice how to get more number of variables from the keyboard using the array and print the same value. In the first example, we can get 10 integers from the keyboard and print the same content. So in this program, I can create a single dimensional array in which first I get the array size. If the array size is 5, I repeat the code 5 times to read the individual elements and print the same elements by repeating the for loop 5 number of times. So user can give any value as the array size. So I can create the array that can be accommodated up to 100 variables. So user can give array size below the 100. After giving the array size, we can read the element and print the element. Let's we execute this program. So first it asks the array size. So I enter as 5. So I need to enter 5 elements. So 10, 20, 30, 40 and 50. So the array elements can be displayed here 10 to 50. So in this way we can access any number of elements using the array and print the same value. Once we know this concept, we can easily solve so many real-time problems. For example, if we want to get 6 subject student mark and find the total and average. So in this program, I create an array called A having the maximum elements up to 100 and created two variables called total. It is initialized as 0 and average and its data type is float. First I read the array size and repeat the for loop up to n number of times and getting the initial values. During the scanf operation, I add the individual element into total. After getting all the values, I calculated the total value and divide by the n and get the average value. Then I print the result. It asks the array size. I type 5. First I give the first mark, that is 60, second mark is 50, third mark is 80, fourth mark is 90, fifth mark is 70. And the total value is 350 and average is 70.0. So in this way we can manipulate any number of elements using the array. The next program is to find the addition of n numbers. It almost similar to the previous program. You can try it yourself. The next program is to find the maximum of given n numbers. So in the same way I declare the array and get the array values, and in this for loop I can find the maximum value among the individual array elements. Finally I print the value of the max. So in the same way you can easily find the minimum of n numbers. You can try it yourself. So we know how to create a single dimensional array. So in this part we learn how to declare and initialize the array. Initialize is nothing but when we declare the particular array, we can give the initial value. The syntax is data type, array name and size of the array. Within the braces, we can give the individual element values. This one is the example. So in this way, we can declare and initialize the one-dimensional array. Let's move to the multi-dimensional array. If the array index having more than one subscript, it is called multi-dimensional array. Two-dimensional array is the best example. So this is the example for two-dimensional array. So first part is data type, then array name. Within the square bracket, we can give two subscripts. And this one is the example. First subscript is called row value. Second subscript is called column value. Once we create a two-dimensional array, it should be looks like this. Total number of values can be calculated by multiplying row and column value. 2 into 3, 6. Totally, 6 variable memory location can be created under the same name called A. Each memory location can be identified row value as well as column value. That is 0th row, 0th column, 0th row, first column, 0th row, second column, first row, 0th column, first row, first column, and first row, second column. So these are all called array index, and this is the array name. And this one is the syntax for two-dimensional array declaration as well as initialization. I already told initialization is nothing but when we declare a variable giving a initial values. So data type, array name, row and column subscript that can be specified by two different open braces and closed braces. This can be easily understood by this example. So this array can contains 4 rows and 3 columns. Let's see how to read the two-dimensional array values and print the same value. Suppose we want to create two-dimensional array like this, that is 3 by 3 matrix. So I declare a variable like this, a of 3 of 3. If I want to read the array, I can use the first for loop for row, second for loop for column. So I should use for loop within for loop, that is nested for loop used. So in which I want to enter a particular element, the entered element should be in the particular index value. So for the first iteration, I and j value both are 0. So a of 0 in that location first element can be stored. After iterating all the times, we can read all the elements in the array. Then we can use again nested for loop to print the element like this. Let's execute this program. So it asks the first element of the array. So I type 1, 2, 3, 4, 5, 6, 7, 8 and 9. So using the nested for loop, we can easily get the two-dimensional array. Let's see one example program to demonstrate the usage of two-dimensional array. This program to add two different matrices and the result can be stored in the third matrix. It is almost similar to the addition of two numbers. In addition of two numbers, we can add the individual two elements and stored into the third variable. But here we can add two different matrices, each matrices having 9 elements and the result also having the 9 elements that can be stored in the third matrix. For this I can declare 3 matrices here. So in this part I can read the first matrix value. We already know two-dimensional array elements can be read by nested for loop. So in this mechanism it reads the element of the first array. So I again use the nested for loop and I read the second array element. After that I again use the nested for loop. in which I can add the individual two array elements and stored in the result in the third array element. This program may have more number of lines, but we have repeated code only. If we know how to read the two-dimensional array element, we can repeat the same in the second array also. Using the nested for loop, we can do the particular operation here and finally print the particular array element. So this program can add the two different 3 by 3 matrices and store the result into the third matrix. Next we see about the pointer concept. Pointer is nothing but a variable. It stores the address of another variable. When we declare a variable like this in our computer memory, it is organized into different locations. Each location has identified unique number called address. When we declare a variable a, any one of the free memory location can be assigned as a. It has a specific address called 1000. If we store this address value into another variable, that is called pointer. So pointer is nothing but storing the address of another variable. And this is the syntax for creating pointers. Data type, asterisk symbol and variable name. This is the example. Integer asterisk variable name is p. So this variable can hold only the address. Let's see this example. Integer a equal to 10. A is assigned in somewhere in random access memory. Its address is 1000. Its value is 10. Then I create another variable called pointer variable. It is the pointer variable identify the prefix called asterisk symbol. So when it's declared, one of the location can be assigned as pointer variable. It has its own address. When I assign a address of the a, ampersand means address of the a into pointer variable means the address of the a is 1000. That value can be stored in the pointer variable p. So this variable can hold the address of another variable that is called pointer. The meaning for the pointer is it points to the particular address. So we can indicate the pointer like this. This pointer point to the particular variable. Let's we execute this program. So I declare here two variable. One is normal variable having the values 10. Second one is the pointer variable. The address of a can be assigned into the pointer variable. I print the value of a and I print the address of a. So it prints the value of a is 10 and address of a is 10200. The next concept is address of operator. The ampersand symbol is called address of operator. Using this symbol only, we can assign the address of the particular variable to the pointer variable. We already used this ampersand symbol in our previous programs. So in the simple program, when we use the scanf statement, we can use the ampersand symbol before the variable name. This means we mention the address of a instead of the variable a. So this ampersand symbol is called address of operator. The next concept is dereferencing operator. The pointer symbol is called referencing operator. It refers the particular address of the variable. But dereferencing means using this pointer variable, we can print the actual value of the variable. So in this program, I create a variable called a having the value 10 and assign the address of a into the pointer variable p. I print the value of a using this variable a as well as I print the same result, that is value of a using this pointer variable. When we use the asterisk symbol before the pointer variable, it is acts as the dereferencing variable. That means it gives the actual value of a instead of address. Let's execute this program. So in this previous program, I can add one more line. So using this pointer variable, I try to print the content of the variable a. So first it prints the value of a equal to 10. Then it prints the address of a, that is the location present in the random access memory. Then it again prints the value of a using the pointer variable. So by including the asterisk symbol, the pointer variable can display the actual content of the variable. So the asterisk symbol is called a dereferencing operator. Next concept is called void pointer. Usually, pointer variable can be declared belongs to any particular data type. But in case of void pointer, if you want to declare a pointer that can be not associated with any particular data type, then that pointer is called void pointer. The syntax for creating void pointer is void is the keyword, then asterisk symbol, then pointer variable name. And this one is the example. Using this void pointer, we can assign any data type variable address to this particular pointer. Let's we see in one example. So we already declared that asterisk p is a integer data type. So I remove this integer into void. So asterisk p is the void pointer. So in this void pointer, I assign the integer variable address to this pointer p. Then I execute this code again. So it shows the actual value of a as well as the address of a. The next concept is null pointer. Null pointer is nothing but when we declare a particular variable, we are also able to give the initial value. For example, if we declare an integer variable, we can give the initial value as 0. In the same way, pointer variable also can be declared in the initial value, that is called null. So the syntax is data type asterisk symbol pointer variable equal to null. So this is the example. And let's we discuss pointer with array. Pointer and array, these two concepts are mostly closely related to each other because array also used addresses for maintaining the array elements. When you create an array with 10 elements, in a single name, 10 different memory locations can be created continuously. The starting memory location is addressed by a of 0. The next memory location can be identified by a of 0 plus 1, that is a of 1. Let us consider a random access memory having the different memory locations, that is called addresses. When we declare a variable a, that can be assigned in any one of the location, for example 1000th memory location. A of 0 is assigned in this 1000 memory location and a of 1 is located in his 1001th memory location. In this way, the continuous memory can be occupied by the individual elements of the array. So we can point the particular element using this starting address. That's why the array and pointer concepts are closely related to each other. So in this video, we discussed about what is array, what is the need for the array, how to create a array using the simple program. And we also discussed about the pointers with the example program. In the description link, you can download the notes, and if you have any query, you can comment it. All the best.